Good morning, and we are very excited to continue and build on great ideas we heard yesterday. As Seth mentioned, we really value your input. We have an amazing group of team members and an outstanding advisory board. So we want your feedback. We want your input. And as Seth mentioned, we're recording. We are capturing in the chat. So even if you say it out loud, if you would type it in the chat, then we have a recorded written version there. And then also we have folks taking notes. So thank you for your participation, and we're ready to roll with our education portion. We have one advisory board member, and I don't believe she got introduced yesterday, Bree Owens. And I saw Jake Owens. Is that you, Bree? Juan, do you see Bree?
No, I think I haven't seen her. Yeah, so when she pops up, we can probably ask her for introduction in some break we may have. So right. Yeah, go ahead.
When we come back from our coffee break, we'll double check to see if she's here with us. Okay. So welcome to the education section for the advisory board meeting. And Juan shared with us this great visual yesterday as we introduced. So you saw how all of these components fit together and interact with each other. The last section today focuses on the vision for education and how education relates to these other areas. So our portion focuses on STEAM education, so the integration of art into STEM education. And I will give you a vision and overview of all the education components, and then different team members will talk to you about specific things related to this vision and overview. I'm Kathy Cape Trundle. I'm a professor in science education and researcher at Utah State University, and I'm the education coordinator for the project. So I'm going to answer some questions for you about the education components. First of all, who are we? So our team is made up of teachers, researchers, and those are education researchers, and scientists. We have 3 scientists on the education team: an entomologist, Caitlin, forestry with Rita. Rita is a glutton for punishment. She has a PhD in science education and forestry, and then earth science with Larry, and they're going to talk with you later. But we also are interfacing with the grazing scientist. So what we're doing is we want to make sure that we're developing a curriculum. So we want to make sure that when the rubber hits the road, that it will help and support teachers and students. So we have teachers giving us the reality check and co-authoring with us. We have education researchers in all the areas for STEM and STEAM, and that's to make sure we are grounded in research. So everything we're doing is grounded in extant research, educational and cognitive psychology research, and we're doing research on the things that we are developing. So it's all research-based. And then with our scientists, we want to make sure that everything is scientifically accurate and that it represents what scientists do. Our team also includes students. We have 10 STEM ambassadors in our budget per year. So that's a possibility of 50 different undergraduate researchers throughout the life of the project. And we're going to come back to you and ask you on how we can make sure those STEAM ambassadors interface well with the grazing research. We have grazing research that you heard about yesterday. We have educational research that you're hearing about today. So how can those undergraduate researchers best interface between the education research, the education implementation in the schools, and the grazing research? We also have K-12 students who will be summer interns with the grazing research. They will also be bee ambassadors with our school gardens, and they will be student researchers. We have 2 graduate research assistants. We have 1 this year, and we have support for that graduate research assistant for 4 years. That's C.U. Wu, and you'll meet her when we do the education discussion. And then we'll add another graduate research assistant next year who will work with us from years 2 through 5. So the next question is, where are we? And we are located currently in 3 different schools. One is Walquest Junior High School, and I'll show you geographically where that is in the next slide. But Walquest Junior High School is supported in the beginning with a seed grant, and we started working with this seed grant from Utah State University in 2021. And as you can see, we already have the school gardens, the raised beds installed, the greenhouse, and the storage shed is installed. This school also received additional funding for an outdoor classroom. So Walquest Junior High School, we're already gathering data. The data from this seed project is informing the work that we're doing with Edith Bowen Lab School, which is here on the Utah State Logan campus. It is a K-6 school. And then Wellington Elementary is down near Catherine, near Price. Ultimately, we will have 2 elementary schools, these 2 elementary schools, 2 middle and junior high schools, and then 2 high schools. And they will be clustered, 2 in northern Utah, 3, 1 at each grade level in northern Utah, and 1 at each grade level in central Utah. Here's where we line up geographically. Edith Bowen Laboratory School is on the Utah State Logan campus. And in case you're familiar with Napoleon Dynamite, Napoleon Dynamite's home in that movie is about 30 minutes north of Logan. So we are right near the Idaho border. And then Walquest, our junior high school, and the Seed Project, that partner school is north of Ogden and south of Logan. And Logan and Ogden are north of Salt Lake City. Logan is about an hour-and-a-half north of Salt Lake City. And then Price is where the Utah State Eastern Campus is. Catherine Vela, Dr. Catherine Vela will talk to you later about the integration of mathematics education. She's located on the Price campus, and we will have 3 schools clustered around Price. Juan, Jennifer, and I, and other members are in Logan. So we'll have 3 schools in northern Utah and then 3 in central Utah. So the next question that I want to address is, what are we doing and when are we doing it? So the first column shows you the program activities that we have. In a moment after I speak, Rita is going to talk to you about the gardens and those sustainable gardens. So we're planning, installing, and maintaining gardens in elementary, middle, and high school. The E is for elementary, M is for middle or junior high school, and H is for high school. We also are developing a curricula for different grade levels, and we will be hosting camps. I'll be talking to you a bit more about the curriculum development, and then Catherine will talk to you about mathematics integration, and Aurora Vela will talk to you about arts integration. So it is a STEAM integrated curriculum that is based on garden-based learning. And then we have professional development, citizen science. Larry Krissick and Caitlin Campbell are leading that effort, and Campbell will talk, Caitlin will talk to you about the citizen science components. And then we have outreach and dissemination. So if you look at this timeline, I hope the message you take away is the work is staggered. We work with elementary schools for the first 3 years. Right now, we are in development. The first year with each grade band is development. The second year is piloting what we developed in year 1. And then in the third year, we do the research component based on what we learned with the pilot data in year 2. So it's sequential in terms of development, and it also is research based. So we develop, we pilot, gathering data, We revise based on the data, and then we implement with the research in the third year. And those are staggered so that we are sequentially developing. We're only developing one set in the first 3 years. Also, I want to mention here, we will have camps. We will have 2 camps in years 2, 3, 4, and 5, one in Logan and one in Price. The ones in years 2, we will pilot the camps in year 2 at the elementary level. We will do research on those based on what we learned with the pilot in year 3. We'll have 2 camps for middle school and high school, one in Logan and again, one in Price. That will happen in year 4 for piloting based on what we learned. We'll offer another 2 camps in year 5 and conduct the research on those camps. The importance of the camp is that it helps us better interface with the community and also with families. So the next question again is, what are we doing? And I'm going to give you an overview of the K-12 curriculum. In that K-12 curriculum, it is garden-based learning. Rita and I have done a systematic, rigorous review of the research literature on garden-based learning for the past 30 years. So everything that we're doing related to garden-based learning is based on what we know from the extant literature. Rita will talk to you more about the garden-based and sustainable gardens in the next presentation. As I mentioned earlier, the K-12 curriculum is STEAM integrated. We are looking at, right now, Ag in the Classroom is based out of Utah State University in Logan. So we're looking at the Ag in the Classroom lesson plans to make sure we're not duplicating and that we're adding value to what's already out there and the great lessons that they already have. One thing an area of need that we identified for this grant are lessons for mathematics, for ag education, and also art. So we do an integrated STEAM curriculum, and Catherine's going to give you an example of that for mathematics education, and Aurora's going to give you an example of what that looks like for arts education. But each lesson is integrated for STEAM where it's appropriate. Some lessons are forefronted with science, some are forefronted with mathematics, some are forefronted with the art, with the other content areas integrated in. Some of the lessons, many of the lessons include citizen science, and Caitlin and Larry will talk to you about that. And by the way, on the arts integration, that also is based on the extant literature. A colleague and I have published a systematic, rigorous literature review on arts integration into STEM, and everything we're doing for arts integration is based on what we know from the extant literature, research literature. We're using a 3H learning model, and that also, again, is research-based and highly effective. Some of you, especially those board members for the education components, you're familiar with a 5E probably, and the BIBE model for a 5E learning cycle. And we're probably all familiar with hands-on and inquiry. Okay, the difference between the 3H model and the 5E model is that, if you'll notice, the hearts-on, the affective or emotional, is given equal weight to the hands-on inquiry and the cognitive heads-on learning. So with hearts-on, that's based on what we know about the importance of emotional connections for effective long-term learning and conceptual change. So that comes out of cognitive psychology literature and the psychology literature on the importance of emotional connections. So we do the hearts-on for emotional, the hands-on for the inquiry, and the heads-on for the cognitive. The importance of the heads-on is that if we only do hands-on, then it's activity mania. And what that means is it looks like science education. It looks like inquiry. So it looks like kids are learning, but they come away having fun. They've engaged with materials. They can tell you what they did, but they can't tell you the bottom line on what they learned. Hearts On is student-centered. It's teacher-planned, student-centered, and student-directed. Hands-on is teacher-guided, still student-centered. The heads-on is more teacher-directed, but it is a balanced curriculum. And again, it is based in the extant literature, research literature. We also are including citizen science, and Caitlin and Larry will talk to you more about the importance of citizen science, but we're using the citizen science in the garden-based learning. And then we will have supporting teacher professional development. So this is the education overview of all the components, and we will discuss those with you later. And also you're welcome to ask questions. So we looked at what are the important components in the standards for the grade bands that we're working with, and what fits with garden-based learning and integrated STEAM learning in these contexts. And we identified unifying concepts. Our overarching themes for the curricula include biodiversity, sustainability, and cycles. And those are the content, the pieces of content, the concepts that we are making sure to include in our lessons. And the unifying concepts have been vetted by our scientists, by our educational researchers, and by our teachers. And the last component the next to the last component, the last component is our research, is the outreach. And these are three things that are unique and we think are pretty cool. We are developing and self-publishing a children's book. This is based on a model that was developed and used for this Breakfast Moon book, which was written and published by the Astronomical Society of the Pacific. And I serve on an advisory board with that team. So they have informed our process on how we will develop a children's book on sustainability and on biodiversity for this project. That book will be self-published. We have money in our budget for the publishing, for a children's author and a children's book illustrator. That will be developed in conjunction with our project grazing scientists. So this is a place, and also with our extension folks. So this is a point of collaboration for all three components of this project. The second one that we think is pretty unique and exciting is we are doing STEAM career documentaries about our scientists on this project. So it will include videos, and we have money in our budget for a professional videographer, and Aurora will talk more to you about this as it in her section. But basically what we will be doing is having children, if you're willing, scientists, grazing scientists, the children, the elementary children, and the middle and high school students will interview you about your research. And now, why is this important? Who you know in science, who children know in science as scientists, and what they do when they feel personally connected to a scientist, that's part of Science Capital. Science Capital involves what you know about science, how you think about science and thinking like a scientist, and what you do that's related to science. And then the last part is who you know. The higher a child's science capital, the more likely they are to pursue a STEM career in the future. And this focuses on science capital because the research literature, and this is in psychology and also in the education research literature, is that the higher the science capital, the more likely a student is to pursue a science career, a mathematics career, or an engineering career. not so much so a technology career, but the research is still ongoing with that. But we will be asking you to participate in those career videos. Oh, and then the last one, the outreach boost. This is a point of intersection also. We will have, as I mentioned earlier, STEAM ambassadors, undergraduate researchers who will work in the schools and on the grazing project. Hopefully well, we have money in the budget to have interns from the high schools working on that grazing research and undergraduate researchers working on that grazing research. We want your input. We want some of those STEAM ambassadors, the undergraduates, to come from your departments, to come from extension, to come from wildland resources. And some of them will come from education. So we want that to be an interdisciplinary team of STEAM ambassadors. But those outreach booths will be developed with our students, our K-12B ambassadors for pollinator conservation, and also with the STEAM ambassadors who are undergraduates. Those outreach booths will mostly be at gardeners markets, farmers markets, the county fairs, and the state fairs. So that's another point. Eric and I have talked about that. A great place for us to interface in terms of outreach. And last but not least, we are doing research, as I mentioned, and on this one in particular, we're doing research on STEAM careers and children's interest in STEAM careers with pre-data, mid-intervention data at the middle point of the academic year, and then also at the end of the academic year. So by participating in this garden-based learning integrated curriculum, does this, and watching these documentaries, does this have an impact on their interest in pursuing a STEM career? So are we touching the future in terms of that STEM pipeline for careers? Also, we want to emphasize that we want to make sure that the K-12 students, the teachers, and the undergraduate students have an opportunity to participate in meaningful ways with the grazing research, because that's part of what they do in their science capital. So, and now last but not least, our efficacy research. We are, as I said at the beginning, everything we're doing is based on extant research, but also our efficacy research. Right now, during the development year for elementary, we are identifying, with the help of a psychometrician. I failed to mention Bill Boone at the beginning. We have educational researchers, of which he is one. Bill Boone is at Miami University in Oxford, Ohio. And he is identifying validated, reliable instruments for us to use for data gathering from teachers, from children, and also from parents, from families. So right now he will have those instruments ready for us to evaluate in February. And then we'll do our initial data gathering for the pilot studies in elementary in the fall. So everything we're doing is research-based and scaffolded with that research. Okay, now any questions for me? And Rita is going to moderate here for me and monitor the chat. Any questions that you have about what I just presented?
So Kathy, I had one sort of big picture question.
Yes.
And I don't know how easy this will be for you to answer, and I'm not trying to put anybody on the spot, but yesterday we spent a lot of time hearing about some pretty detailed scientific aspects of the research components of the project, and now today we're shifting gears to talk more about the education pieces. I think you referred back a little bit to a couple of the points from the extension program from yesterday, but I'm wondering if you could just highlight like a few real concrete connections, I guess, between some of the research elements we heard about yesterday and like some of the education components that you're talking about. I mean, I think in a big picture, it's clear that there's connections, but are there certain threads that really help, are at the center of those connections between the education and research components?
That's a great question, Corey. And yes, we have very specific intentional connections. And this is how the children will be participating in citizen science. In our gardens, Rita's going to talk more about the gardens, but we will have 6 raised beds, one of which will be a smart foodscape. So we are planting the same plants that Jennifer talked about yesterday. Every school will have a smart foodscape. We will have bee homes to monitor, and we will monitor pollinators, and we will be monitoring the weather. So we will be comparing our data from our smart foodscape to the smart foodscapes that we have in extension at the producers. So on those pilots with the producers, we'll be comparing the pollinators. That's one thread to share across those. Rita's going to talk more about the gardens next. And then after Rita, Caitlin and Larry are going to talk. Caitlin's going to talk about it, and Larry will chime in on citizen science. So our citizen science component is our most direct connection. Yes.
No, that's great. Thank you. And it sounds like we'll hear more about a lot of those specific connections in the subsequent presentations.
Yes.
I also just wanted to mention that I really like the idea of science capital that you were talking about. I personally have not heard that term used before in this particular way. So that seems like a pretty compelling idea to be kind of at the heart of some of your proposed education activities. So
yeah, and it's not that people don't use that framework that much in the US. It's just becoming in the US, but they've been using it for a while in Europe and especially the UK, but the research is really clear on that. So that's why we connected in with that science capital. Yeah. Also at our sites, Rita's going to talk about this. We will have iButtons, we'll have drones, and Rita has done quite a bit of work related to the drones and the mapping. So we'll be mapping our schools too, like they talked about with the GIS. Or GSI, Rita, which I'm a little dyslexic. Okay. Yeah.
Yeah, and Rita, I totally see the connection between the identity work that a lot of people are doing and the notion of science capital. I could see those connections. So that's great.
Yeah, we're calling it science identity, but the science capital is how you create the science identity. It's like what's behind it, right? The components.
Yeah. And also I've worked on a project with National Geographic, and they do those video clips on Nat Geo Explorers. So we're going to model it after that to, what's interesting and cool. And we thought it would be a really good idea to have kids directly interviewing the scientist in the field where they're working. So we want to make sure that our kids are making a very direct connection to what they're doing at the school, to what's happening in extension, to what's happening out on the grazing field. So other questions?
Good morning, Kathy. This is Wei Wei.
Hi.
Thank you, Corey, for asking some of the questions that actually in my mind as well. Another question that I have is, how do you, because you have like across K-12, like elementary, middle school, and high school teachers, like involving in this project. How will you envision the differences between, like the education that you were saying, curricula, like activity will looks like, like across different, like a grade areas? Yeah.
So let me make sure I understand the question. How are we going to make sure that we are articulating across the grade levels? Is that correct?
Yeah, because the example that you were showing, like is like a children's book, right? And then I don't think, like in the high school, like you were using the children's book, like in this sense. So how would that be different? Like if the contents are very similar, but then what's the activity what this like you were using in the different like a grade levels?
That's a great question. The children's book will be targeted for elementary. But it can also be, middle school students with a beautiful picture book. I taught middle school, and, a beautiful picture book to share those concepts. We're planning to do that. We've already identified classroom library sets based on work Rita has done. Rita and Caitlin have been doing garden-based research in schools and garden-based projects in schools for about 6 or 7 years. So based on what they know and what they've used with schools, we're already compiling those libraries. One example, and again, we have scientists on our education components. Caitlin is an entomologist and Larry's an earth scientist. Caitlin hopes to interface with the entomology research and the pollinators, the insects, but the wildlife components. We have a bee expert right here in Utah down at the Tooele campus. And I always get his name wrong. Is it Joseph I always want to say Campbell, but it's Caitlin
Wilson.
Joe Wilson.
Wilson.
Joe Wilson is down at Tooele, and he's done a gorgeous, beautiful book on native bees. We have amazing native bees and the variety of native bees in Utah. So it's a stunning book. It's really like a coffee table book for native bees. He has an amazing poster also, and they are to scale with each other. So kids can see how big some of these bees are and how tiny some others are. And we already have that hanging up in Wildquest Junior High School, and the kids are really gravitating to it. They're around them looking at the bees all the time, even though we've got snow today. They're very interested in those bees. And the other part, Wei, that I'm getting to is Joe has done a graphic novel on bees, which is perfect for middle school and high school. So we have thought about that. We are developing a children's book for use primarily with elementary and families. Another thing that we're planning to have students do is the high schoolers and the middle schoolers partner with our elementary school and read to them. That can be part of that ambassador that they're connecting with the elementary schools. So we want some, to use a pun intended, we want some cross-pollination between our grade levels. Good question.
Thank you.
Also, the curriculum will be written in grade bands. I don't know if that's what you're wondering about. So there'll be a lower, then there'll be an upper elementary, then there'll be a middle and a high school. So there will be differences between the grade levels, yeah.
And if you look at this way, I mean, this is what I mentioned, elementary, middle, and high school. We also, when Catherine shares the lesson plan with you, and also during our breakout session this afternoon, we have a specific part on the lesson plan template for articulation across the grade levels. So looking at those learning progressions. So yes, we are addressing that. And our teachers are from across different grade levels. So they give us the reality check. So we have that in that team, that very diverse team, we're making sure that we're addressing those issues across grade bands and grade levels.
Thank you. Yeah, that's great. Yeah.
Any other questions? Okay, our next one, this one is food for thought, and that pun is intended too in terms of smart foodscapes. But each presenter, we have 5 presenters for education. Each of us will pose food for thought. These are questions we are asking of you. It's something we want you to ruminate on, and we will come back and discuss these in the hour-long education discussion this afternoon. So the question I'm posing to you to think about, to ruminate on, is how can the undergraduate and K-12 ambassadors best support the schools and connect with the grazing research? And these will all be presented to you again when we're ready to discuss them, but this is what we want you to be thinking about. How can we make those meaningful connections? And using and building on Juan's beautiful model from yesterday, I turn the floor over to Dr. Rita Hagovit. And I will stop sharing.
Okay, thank you, Kathy. Let me get my presentation up here somewhere. Uh-oh. disappeared on me. Hold on,
And Rita is presenting on the sustainable gardens.
if I can find it. It's here. How did that happen? Okay. Sorry, been having a few technology issues this morning. Here we go. All right. Okay, so we're ready to get started. I'm going to talk to you this morning a little bit about sustainable school gardens that we're planting in the schools. My name is Rita Hagovic, and I'm a professor at UNC Pembroke in North Carolina. So we're out east, and I am the graduate director there of science education. So I work with secondary level, which would be middle and high school. I'm really excited to be involved in this project. As Kathy had mentioned, Caitlin and I have been working on sustainable school gardens and garden-based learnings in the schools in our region in North Carolina for about 6 or 7 years now. With great success. It's been lots of fun. We're excited about this project and how we can partner with Utah State, especially. University of North Carolina at Pembroke is the only school in the United States that was founded by American Indians for American Indians. And the university sits in the Lumbee tribe, which is the largest tribe east of the Mississippi. So we're also very excited on how we can relate our context to the Utah context as well. So we are establishing sustainable school gardens in these schools. These sustainable school gardens are organic gardens, meaning that the things used to build the gardens as well as maintain the gardens follow the principles of organic gardening and avoid the use of chemicals as much as possible. These gardens are accessible, affordable, and equitable. And that by that we mean that these gardens have multiple access points. So, you know, lots of people can come and use the gardens, and the gardens can be placed in different areas. So right here on the bottom, you see this is something called a forest garden, where you can place the gardens in the forest itself. Container gardens, raised bed gardens, all of those things are possible. And it is our goal to have the gardens be self-sustaining. So teaching ways to collect seeds and maintain these at a very low cost. The gardens are around a systems thinking approach, meaning that we want to, in the curriculum, make sure that we look at different systems and how all of these systems connect to each other. So with that, the gardens are a holistic approach and involve civic engagement. So we want the community involved, families involved, lots of different people involved in the school gardens. And most important, they're fun. So the best thing about working outside is it's a lot of fun. And so these gardens are meant to incorporate play and just having fun playing in the dirt. I'll interject a fun little story here. You know, when the school shut down and all the students sat at home staring at computers for a while, when we started up the school gardens again, one of the things these kids love to do is just play in the dirt. Playing in the dirt is a lot of fun. All right, so what's in these school gardens? Well, each school will receive 6 raised beds. These beds are 4 feet by 12 feet by 18 inches high. You see at Walcrest, they doubled up. So they have 2 levels here, which is fine. They had a low area here. There's a big drain here in the middle. So they wanted to make their raised beds a little bit higher. They were concerned with flash flooding. So that's what they did, and that was great. The beds will have one that's a Foodscape and one that's a wildflowers and herbs. And of course, the schools can mix these up. You know, they don't have to just have a Foodscape bed, wildflower and herb bed, and then 4 that are vegetables. A garden shed, which is 7 feet by 7 feet approximately. 2 large rain barrels, which will form a rain garden. 2 large compost bins, which are made out of recycled plastic, basically. A greenhouse, and this greenhouse is a little bit larger at Walcrest, but 17 feet by 20 feet approximately. Garden tools, and they will also receive native bee homes. In addition, the schools will receive some monitoring equipment so they can do wildlife monitoring. There's 2 weather stations, an outdoor weather station and an indoor weather station for inside the greenhouse. Eye buttons that will measure temperature in the native bee homes. A drone so they can fly their gardens and fly their campuses. Usually once a month is what we recommend so they can see changes over time. Bioacoustic monitors to do soundscapes, and critter cams to look who visits their garden for predation. And in addition, they will receive classroom materials. So some of these books that the schools receive are for the teachers to help the teachers with the gardens. That would be the Square Foot Gardening book, for example, the Bees in Your Backyard, and the Naturalist Notebook. The students will use science journals or nature journals extensively to do their observations in their gardens. And then the Native American Gardening and Keepers of Life are also reference books for the teachers. Of course, field guides, and then books that will help the teachers to do the teaching to the students in their classroom. So there are both kinds, reference books and books to use with the students. Okay, the schools will receive approximately $30,000 in supplies to do these activities. It's an indoor-outdoor approach. So there are some things they will do indoors and some with the students, and some things they will do outdoors. So the first step is for the school to plan where they're going to put their school garden. This is an important decision. So this is the plan from Walcrest Middle School that you can see here, the one that's already under construction. Here are some students helping fill the beds with the soil. So planning is the very first step that the school undertakes. Then the next thing that happens is they have to order all these supplies, which has been challenging during COVID, but that seems to be getting a little better. After they order the supplies, setting up the space, then enact the STEAM curriculum. And the planning does not end with planning the school garden, which is kind of really fun. The planning continues throughout the project. So this is from an elementary school in North Carolina as an example, but they have to plan where to put everything too, and then monitor where they put everything, and then look at if they want to put things there again. And then finally, the students and teachers all participate in the research and the process of science, which they will then share with others. So that's kind of the how it works. All right, so we are going to use technology in this project. And one way we feel like the education component could possibly interface with the extension and the research component is by using GIS and databases. Now I found this, I have not used this, but I think this has potential. There is a public garden data model available in ArcGIS from Esri, so I think that's something we may want to check out. I thought that was kind of cool. And then students love to create story maps. So if the schools created story maps and then those story maps also interface with the research and outreach components, that might be a really good way to kind of connect these pieces together. I'm unsure which type of geospatial technology has been proposed in the project. I couldn't pick it up from the presenters yesterday, but I do want to let everyone know that all K through 12 schools in the United States have access to the ArcGIS software from Esri online free of charge. All right, so when we thought about how to design this, we took into consideration what we have learned from the literature about best practices in garden-based learning. So from the literature, this is 30 years of research on garden-based learning in science in schools. Here are some of the successes and challenges. One challenge is there's a lack of an integrated curriculum. So in this project, we are addressing that challenge by developing an integrated curriculum. Adequate budget. The grant is helping them out with that to get started, the schools. Active stakeholder involvement by having a whole group of people supporting these schools, STEM ambassadors, researchers, educational experts, scientists, and then helping get the community involved will help with that. And then longevity. So this is a 5-year grant. It has, in the research, it shows that school gardens that are ongoing for more than 2 growing seasons have a much greater chance of success. In other words, the practices become a part of what the school does. Okay, questions?
Hey, Rita, this is Doug. For the drone work, are the students going to be just using the raw imagery from the drone, or are they going to be processing it somehow?
Yeah, so we are getting mapping grade drones, but not the really expensive ones, because the kids we want the kids to be able to use them.
And crash them. Yeah.
So, you know, they are mapping grade, but they're not like, you know, really expensive, right? They're like $500. Sure. Okay. And yes, no, we will have to help them process the data. That's a good question. Yes. So that will be something we help.
Rita, there's a question from Kathy V to explain what a story map is.
Okay. So a story map is a product by Esri. They also have actually gotten even more sophisticated. There's something called experience maps now, but we'll stick with the story map. And they're templates, and they're really easy ways that anybody, the kids have used them, they love them, can use to create these maps in which you let the map tell a story. So it's an integrated presentation. So you have the map, you click on the spot, and then up can come a movie, any kind of presentation. So it's like an integrated map that tells your story. So if we had each school develop a story map about their gardens and what they've learned about, you know, foodscapes and bees, then we could have them share those different story maps. There could be a story map created for this entire project, for that matter. And what's nice about story maps is they're shared online with the world, for that matter. If you Google it, you'll see all kinds of story maps that come up. Also, teachers use them in their teaching. So that's another benefit of a story map.
Hey Rita, this is Tim Bateman, and I just want to say that that's really exciting to hear that they have access to all this. I use story maps for some of my work, and it's a very powerful tool. Very great to hear that that's available to them. So
Not only do they have access, but there are hundreds of already pre-written lessons that teachers can use.
that's exciting. Great to hear.
And what's nice about this is just by using this in this project, you're preparing students for future jobs, right, for them? We all know there's a huge deficit of people that are working in this field.
So Rita, this is a way thank you for your presentation. I don't know the regulation for Utah, but I remember when like when we're doing like a flying drone in Indiana, I think there are some regulations about, like can you fly or can you not? So I think it would be good to, I don't know in Utah, but probably, like can check in a little bit that, yeah, and then just make sure that everything's gonna be okay.
We'll have to work through that. That is a state by state regulation.
Yes, yeah, I know that. Yeah.
The laws tend to be more strict in the East than the West.
Okay. Yeah, I just don't want everybody, like get in trouble for that, like.
So they are super strict in North Carolina. They're less strict on school grounds than they are on university campuses. So the laws are different depending on where you're using and flying the drone as well.
Yeah.
So I'm very familiar with the laws. It took us, by the way, it took us 2 or 3 years just to let the university, just to get our university to let us spend grant money to buy the drones for the school. So I am very familiar with the regulations.
Yeah, I know. Yeah, I know I run into some trouble, so that's why, like it's a lesson learned experience. Yeah.
Yes, it's painful, isn't it?
Yeah. And another question that I have is, so sounds like it's a big project, like for the teachers. So did you envision that they're gonna, like for the teachers, because they starting from the, like building the, like the garden beds, like designing and the whole thing. So it's like the entire semesters or, or the entire years of project for the teachers, and how are they, because they are not just only gonna teach that gardens, like learning, right? They have other content area they're gonna teach. So how does that balance out for using, adapting this project and also doing something, their regular everyday life? Yeah.
Yeah, that's a good question. So think of the gardens as being ongoing, like its own life separate from the school. So it's kind of like an outdoor learning lab that the teachers can decide when to use it, how to use it, how much to use it themselves. Then there are the summer camps, remember? So then, of course, the summer camps will extensively use that space because that's when things are really growing. And so it's kind of like they can use it as much as they want whenever they want. And that seems to work really well because it's a small space. And in a school, you have anywhere from 500 to 1,000 students in high school. There's no way they could all use those few garden beds, so it's kind of works out that way. But that's a good question.
Thank you for the great questions and the interactions here. Rita, do you want to share your food for thought with the group?
Yep. So our food for thought is how can we connect the school gardens to the grazing beds? So I have just a couple questions. Do I have time, Kathy, in the chat?
You can put them in the chat where we can come back to those during the education discussion.
Okay, that's great.
And then this is the next one up is?
And the next one up is Dr. Caitlin Campbell with Larry Krissick talking about citizen science.
Thank you, Rita.
Hi, everyone. Can you hear me okay and see my screen? Okay, so hi, I'm Caitlin Campbell, and I'll be presenting on the citizen science content of the education component. Just a little bit about me. So I'm at UNC Pembroke as well, where Rita is, and I've been here, this is my 6th year now. I've been working with Rita doing pollinator conservation work and garden-based learning at our UNCP campus garden and apiary. I completed my PhD at Miami University in Ohio, where I studied insect biodiversity in prairies that had been restored from farmland. I did community ecology and landscape ecology work with the insects. My current research, though, focuses more on pollinator diversity and pollinator conservation in the campus garden and apiary and the surrounding vicinity. But I'm actually really interested in community engagement, and I try to incorporate that in most of my classes that I teach. So I love sharing my passion with others, and being a part of the citizen science piece of the education dream team is really a good fit for me. I'd like Larry now to take a second to introduce himself, and then I'll continue on with the presentation.
Hey, good morning, everybody. Can you hear me all right? Caitlin, can you see me? Yep. Okay.
Yes.
Got a thumbs up from Caitlin. Thanks. So my name's Larry Krissick. I'm a retired faculty member from Ohio State University from the School of Earth Sciences there. I'm working as a consultant on this project, primarily helping with the physical science side of citizen science projects, as well as other aspects of the program. Weather, climate, soils, and the like. I worked with Kathy on a number of projects when she was at Ohio State a while ago. And I do have ongoing interests in science education that I've been continuing to work on throughout quite a while. The one other thing I'd mention is that I also have a connection to Utah in that our department at Ohio State for 75 years has based its geology summer field camp out of Ephraim. And so for about 10 years in the mid 1990s through the early aughts, I was in Ephraim helping to teach that course every year. So I'm looking forward to working with everybody in the team. And I'll turn this back to Caitlin now.
So Larry and I bring our particular expertise to the table whenever we're helping with the science lessons, but we also are particularly focused on the citizen science components. So if you aren't familiar with citizen science, it's also called community-based science. It's simply a way of engaging the general public in scientific work, and this can be in a variety of ways, all different sorts of disciplines, takes many different forms. There's actually thousands of citizen science projects out there. But the most common approach is to have the general public collect data or to upload pictures of things. And then these will go on to some sort of accessible online platform that the scientists can then use that data for their own work. So it's really valuable for several different reasons. One of those is for scientists in particular, the value of citizen science is that you can collect data from a really broad area globally, nationally, at a state level that you might not be able to do on your own or even with your research team. You don't have to pay these people. These people are eager to collect data for you, and you get millions of data points in some cases. For example, iNaturalist is one of the biggest citizen science projects, and it's basically just a process where volunteers just snap pictures of anything alive that they see, and they post it up on the iNaturalist webpage, and then people identify them for them, and then you have all these data points about distributions of organisms around the world. From an education standpoint, it's valuable for teachers because it gets people outside. A lot of these are based on outside learning and outside collection of data. It's also a great way to get people of all ages involved in science, observing, practicing the scientific methods, and actually perceiving themselves as scientists. For individuals, these projects are just like fun and they're really rewarding to do. People, it's kind of like a Pokemon game where you got to catch them all and take as many pictures as you can of all these different things. I use iNaturalist regularly just so I know what is in my yard. I found this weird mushroom. I'm going to take a picture. Maybe somebody out there knows something about it. It's also something that you can do with your family. And it's just, something that gets people outside, connected together in groups or individually. in our project, we have, so far we have 3 key citizen science projects that we're focusing on to use with the education components. So the first one is the Great Sunflower Project. And for this one, originally it started off focusing on just sunflowers, but since then they've broadened to any flower. And basically people will watch flowers for 5 minutes and observe pollinator activity at them. So they'll document the different kinds of pollinators that are visiting them and just upload their findings about how many pollinators they found visiting those flowers over that period of time. And so this allows researchers to see regions that have high pollinator activity, low pollinator activity, and also which plants are particularly attractive to different sorts of pollinators. Another project that we'll be using is definitely iNaturalist. This is a great citizen science project because people just snap pictures. It's a way to use technology in the classroom for good use. And they can just simply upload the pictures to the web page. What's really neat is that you don't have to know anything about identifying anything to do this. For the Great Sunflower Project, you have to know some really basic identification stuff to be able to say like, it's a bumblebee visiting or a honeybee visiting or a fly or something like that. But for iNaturalist, it actually has artificial intelligence that will suggest identifications to you. And if you pick, their suggested identification, or you can even put your own identification in, it will then be verified by multiple other participants and even experts that are working in iNaturalist. Like I've identified things in there for entomology related things. Lastly, we'll be developing a new project. And this project is tentatively called the Bee Home Project, in which people are going to put out native bee houses like these. They look kind of like bird houses, but inside there's little tiny hollow tubes. And the hollow tubes are what bees like leafcutter bees and mason bees will use in the spring and throughout the summer to have their solitary bee nests. So these are native bees rather than honeybees. Then at the end of the fall, people would collect those cocoons that are inside the tubes and help them overwinter. So they would count them, they'd sort them, they'd upload pictures of them, and then we'd have an idea of what places are being used and kind of the different types of cocoons that are used in these and what they end up becoming when they hatch out. They can take pictures of those and upload them. So this is a project that's in the works, and we're really excited about it because we've had a lot of fun with our native bee houses on campus. We also are going to be putting the eye buttons that Rita mentioned, so we'll have some kind of microclimate data associated with them. Eye buttons will remotely monitor temperature over time and take readings at whatever intervals you set them to. And so then you can connect, maybe the use of these houses has to do with the temperatures that they're experiencing. In this project, we're going to have kind of 2 key parts. We're going to be making these STEAM lessons, and I'll give you an example of that. And then we're also going to be doing just data collection using citizen science. So the data collection could be used for research and education publications. It could be connected to the research and extension of the larger project. And ideally, the data we collect on our wildlife and the plant use, life cycles within the garden, and the foodscapes that are in these gardens will be compared with the same setups that are going to be hopefully in the extension and research plots. So I think that we're going to be putting the bioacoustics and the camera traps out to monitor wildlife at both of those things, but I don't think we can put the native bee houses out at the research plots because we don't want to influence the actual population of pollinators there. We have kind of 4 key topics right now that we're focusing on. We have our pollinator visitation and the connection with weather. So what sort of things are influencing the pollinators at our gardens? You can see here, this is a bumblebee that's kind of hunkered into a zinnia with a drop of water during a storm. We have cloud measurements that we do and a lot of other weather variables. We're going to be just keeping track of general garden biodiversity and the wildlife in the garden using the iNaturalist and also bioacoustics and camera traps within the gardens. And again, the gardens will have those smart foodscapes, so we can specifically look at what is visiting those sort of flowers or what sort of animals are living in those little gardens. And then we'll also have the demonstration extension sites where we can monitor these too. We also are going to be incorporating some stuff about soil quality and sustainability, and Larry's going to be leading those ones since soil is obviously such a key piece of a garden. And then lastly, we're going to have life cycles. These are life cycles of plants and animals. And it's going to be incorporated into our lessons. And a key part of this is going to be the bee home project. So they'll be able to see the whole life cycle of a bee from you put the tubes out and they're empty to you harvest the cocoons at the end. And then you see the babies, well, they're adult bees, but their first day out on the job as bees. And again, these bee homes are also going to be placed at the extension sites. That's what we planned in our proposal, so that we can kind of compare in these larger foodscapes and these little gardens in urban and rural areas. So I'm going to give you an example of a lesson that we have incorporated citizen science into. And so this is a STEAM lesson. We have several components, so keep an eye out for the different pieces of the STEAM as you're hearing me talk. This is called Every Pollinator Counts. So the first part of the lesson is we have the kids come out to the garden and they sit down and they sketch a flower that they like out there. Next, we get to some of the cognitive piece where we're heads on and we're talking about, what do you think affects pollinators? Do you think it's things like in the environment? What about things about the flower that you drew? Do you think your flower is going to have a lot more pollinators than others visiting, and why? Then we have the kids collect actual weather data, and they'll do this using technology that's in the garden, for example, weather station, or they could use it, use smartphones and access it through Weather Underground, for example. They're also going to be kind of doing direct measurements in the field for like cloud cover. Then we do the Great Sunflower Project. They sit down and they will watch their flower that they drew for 5 minutes and keep track of all the little friends that visited. So we have, this is the standard list for the Great Sunflower Project. And so they can kind of pick off the different things that they see and keep track of those. Then they'll share and discuss what they find. They might make a graph or something, just a real quick discussion. Nothing is going to take too much time, but just kind of explain what they were seeing and why they think they saw that. And then the last hearts on piece to this is that they're going to be thinking about, what is a scientist? Who are scientists? And when kids think about scientists, what do you think that they're thinking? They're probably imagining, somebody in a lab coat, right? Some little nerdy person. But we all know that scientists are actually really cool people, and they're not all in the lab. And in fact, the point at the end of this that I want them to get out is that they themselves were scientists. And scientists are diverse people. They're all gender and they're all different colors, and that scientists can do things outside or inside. So I think that is a kind of a piece that I really hope to get across at the very end. So within this lesson, you might have noticed that there was science, there was technology with the weather, and there was also art where they did some sketch at the beginning. But the lesson is actually further integrated into other lessons by Catherine and Aurora to have a stronger math piece. So the data that we collect using the citizen science is then used to make graphs, for example. And Aurora has a watercolor lesson where they will draw these flowers much more in detail than a sketch. So those are our cross linkages. And we're also going to be providing teacher support. Larry and I are going to be providing some resources and references about insect identification, wildlife identification guides, connections with weather. We are modifying some of the data forms associated with citizen science projects to incorporate the weather, for example, with the Great Sunflower Project, which doesn't currently have that. We're also going to have a web portal where we have the teachers able to input these data so that they can be easily shared among the different schools and compared and pooled across grade levels. We're also going to have a weather data training, how to use your weather station, what all this means, what weather even is, and then professional development as well. So we'll have all sorts of information about to kind of help the teachers feel confident carrying out their lessons and have the background knowledge that they need to really carry it out well to the level that they really want. All right, so that is my presentation, and I am happy to take any questions. Thank you for your attention.
Caitlin, this is where I think this is a very exciting, like you're not only including the just, regular data, like a collection, but also the research project for the bees, and really cultivate that pieces of, like the citizen science, not really, because citizen science, one of the criticism was like the participants, just providing the data, but not really engaging in the scientific process. So I think this is very exciting. Yeah.
Yeah, and I think because we have the chance to then work with the citizen science and have it in a lesson, then they actually get to see the full circle of that data being used, and that we can make it into a math lesson or a further scientific lesson. That's what I think is really valuable there. Thank you.
Yeah.
Any questions in the chat, Kathy? I can't see them.
No, not yet. Larry, did you have anything else to chime in on?
No, Caitlin's done a great job of summarizing it. And we're looking forward to having everybody be a scientist.
Yeah, I think so my background is obviously science, but I love communicating science. But I have never actually made a lesson myself until I joined this team. So I've learned a lot too about education, and I feel like I'm a better teacher already. All right.
We'll have time to come back to citizen science in our discussion, our hour-long discussion too.
So my food for thought was how we can best connect the citizen science to grazing research and extension. And I mentioned a couple of opportunities where we're going to have similar equipment across them, but like data sharing and that sort of information will be really valuable for this. So we can talk more about this later. And I'd like to now introduce Catherine, and she's in the mathematics education piece of our group.
Good morning, everyone. Thank you. I'm going to share my screen. So my name is Catherine Vella, and I'm at USU Eastern. So I'm down in Price. And this is my second year here. A little bit of background about me. I graduated from Texas A&M University in Texas. Obviously, I don't know why I said that. In August of 2021. And while I was there, I was also the Aggie STEM camp director. And so I'm super excited about bringing the camps to Utah and working with students and getting them excited about STEAM. So I'm going to go ahead and continue. So Kathy mentioned about our large group and how we're creating curriculum that will be used for our gardens. And so our team for creating those lesson plans start with our education researchers. So we start creating the lessons, and then we're working with scientists to make sure that the content that's in there is accurate and any other connections that maybe we're not thinking about can be made. And then we're working with the teachers to have them review the lesson plans, make sure it's feasible. If they see any other connections that maybe we missed also from the standards that they're responsible for. And so we're all just kind of working together to create this curriculum to make sure it's all inclusive and feasible to do in a classroom. And so our lesson planning process I'm going to talk about the elementary one specifically since that's what we're working on right now, but it'll follow the same process when we start working with the middle school and the high school. So for year one, which is where we're at currently, we're working on drafting them, reviewing them, and revising them. And so we've drafted about 2 or 3 lesson plans for each content area where that content area is forefronted. And then we've been meeting bi-weekly with teachers and our writing group to review those lesson plans and make any changes. And so then what we'll do during year 2 is we'll start piloting those lesson plans and then revise them based on the teacher feedback after they've implemented them in the classroom. And then for year 3, then we will implement our final lesson plans and then conduct research on how those lesson plans went. So Kathy showed you this progress. Kathy showed you this progress during her presentation. And so right now we're currently in the fall and winter of year 1. And so our goal is to have about half of our elementary lesson plans lessons done by January 10th. And so that's about 5 lessons because our goal is to do 10 lessons per content area. So our goal is to have about 5 done, and we're on track for that. And so as I mentioned, we're meeting bi-weekly with the education team to discuss our progress on our lesson plans. And then on the opposite weeks, we're meeting with our writing group to get ideas for our lesson plans. And then we also are meeting with our teachers to get ideas on how we can revise those lesson plans. And so what I'm going to share with you now is a sample math lesson plan that we've already shared with the teachers. So that way we can get feedback on how we can make this lesson plan better. And so Kathy also shared with you the lesson plan model that we're using, the hearts on, where we engage the students and kind of hook them where they have this affective emotion to it, then the hands on, and then the heads on, where the teacher comes back, they have like a class discussion and they label that learning. So the sample lesson plan that I'm showing you is basically designing the school garden. And I know Rita talked about this in her presentation as well. And this is geared towards a 3rd grade level. But if you look at the handout that Kathy shared with you, you can see there's a vertical alignment in there as well on how maybe a 2nd grade teacher or a 5th grade teacher could also implement this lesson plan in their classroom. So the focus is students planning their school garden and finding the perimeter and area of the garden or their garden beds. And so for the hearts on, what I plan to do is have the students kind of reflect on a time when they had to plan to either build something or make something, because then we start getting them to think about why is it important to make a plan and how can we use this moving forward for this project. And then we'll show some images of some sample gardens to kind of give them some ideas. And from those images, we'll start to create a list of things that we need to make sure to include in our plan. So the students will come up with a class list of required items. So then we move on to that hands-on, where the students will work in a group to plan their school garden using all of those required items that we listed from our hearts on section. Then they'll be asked to find the perimeter and area of the garden and all the different items that they're including in that task sheet. And that's included in the supplemental materials that Kathy also shared with you. And then what we'll ask the students to do is to pose 2 or 3 real world math problems. And there's research that shows if we ask students to pose their own problems, it helps with problem solving. And so they'll use their plan to create their own math word problems. And then the class will go on a gallery walk to view all the different garden plans and answer at least one of those questions that were planned by their peers. So then we come back together as a whole class and do our heads on, where we're going to label that learning. And so we'll have each of the groups present their present their garden plan, and then pose one of the questions. And then they get to be like the teacher and kind of walk around and watch their peers answer the question and kind of help them make sure that they solved it correctly. And then they'll have a discussion about the importance of planning a garden and the strategies that they use to find the area and the perimeter, because there's lots of different ways that students could find the area or the perimeter. And then the teacher would pose this question to them. Our food for thought for this lesson is, can 2 shapes have the same area but different perimeters? Or can 2 shapes have different areas but the same perimeter? And then we would ask students to prove their answer by drawing pictures and showing that. And then that would really show us that they have a good conceptual understanding of the difference between perimeter and area, and then also how to find those. And so this lesson plan would be one of the lessons the teachers would do early on in our garden planning, because the students kind of have that buy-in of, ooh, like maybe my plan is what gets used for how we do our layout of our school garden. So I went through that very quickly. So if you have any questions about anything that I talked about, please feel free to ask those now.
If I could chime in, Catherine brought it up, but I forgot to mention it. We prepared a packet for you. It's in the hub. It's at the bottom. If you go to today's session and you scroll to the bottom, there are handouts for the education portion. It includes the lesson plan Catherine just presented and the supplemental materials. It also includes bios for all the amazing teachers that we're working with. We have one teacher who is a certified naturalist for the state of Utah, and another one who did her master's work on Playscapes. That's outdoor learning environments for young children. But be sure to check on that. Thank you, Catherine. I forgot to mention.
You're welcome. And then in the lesson plan, there's also a link if you're interested in the feedback that we're getting from the teachers, and that's how we're collecting feedback from the teachers. We meet through Zoom, and then we do breakout sessions. So that way they have a chance to collaborate, maybe with teachers that are not at their school, but maybe with the teachers from Logan. And so there's that cross collaboration as well happening during our meetings. All right, if there's no questions, I'll leave you with my food for thought. We'd like you to think about what mathematic applications from the project can we use to connect to the schools. And so yesterday I heard a lot about some different data that was being collected. And so perhaps thinking about how we can use that data in the schools to make this research come alive for our students. So we'll talk about that later. And then I'm going to introduce Aurora. She's our arts expert. And so she's going to talk about art education and what that will look like in our project.
Let me double check here, Juan, because this is our coffee break time. Juan and Seth, we were going to take a coffee break now and then go to Aurora, or do we want to go ahead with Aurora's presentation?
Yes, I think let's take a coffee break now so right now is, we are a little bit ahead of schedule again. So
which is awesome.
Until 10:45. Let's take so we have a little more time for the coffee break until 10:45, and then we'll continue with the next presentation by Aurora.
All right, welcome back. We had an excellent interactions via the chat and verbally during our presentations, and we appreciate all the great ideas and that input that you provided for us. Someone suggested, Rita suggested, that I bring you to the hub to show you where our handouts are. I meant to do that at the beginning of the day, but when you go into the hub and you click on day 2 for session 4, education component, and you scroll down to the bottom, there are sponsors. Let's see, there are sponsors and our presenters with bios. At the bottom, there's the session content. There are education handouts. That includes information like our timeline, our education objectives, goals, and outcomes. It includes the bios for all the education team members, including our elementary teachers and art teachers. I failed to mention that. We have two lead teachers at each school, a garden manager at each school. So we will have 18 teachers across the project for the life of the project, and then 3 art teachers, lead art teachers, but their bios are in there. The sample lesson that Catherine shared with you is here. The sample lesson supplemental materials are here. And then also all of our slides for education are here. So that will give you information for you to look at and maybe help you and guide your thinking. All of the food for thought questions are in there for the discussion later. But with that, I will turn it back over to Aurora for art integration.
Okay. Thank you, Kathy. Can you see my presentation and hear me? Okay, great. Whoops, let me grab one thing. I moved my keyboard, but now I need to make sure I can. Just making sure it works. Okay, all right. So my name is Aurora Hughes-Villa, and I'll be presenting about arts integration today as part of the education component. And I truly am part of a dream education team. It's hard to follow up after all those wonderful presentations. So I'm in my 5th year here at Utah State University on the Logan campus. My research focuses on arts integration and students learning through the arts, and my background is in studio art and arts education. I received my MFA from the School of the Art Institute of Chicago, and my focus was in ceramics. So I have quite an understanding of science because of my experience with ceramics, with mixing glazes and firing kilns and all of that wonderful stuff. So I am a professor here at Utah State, and I teach an arts integration course to pre-service teachers. And I have a dual role. I'm also the Beverly Taylor Sorensen Endowed Program Director for Elementary Arts Education, and I direct a program called Arts Are Core. In my director role, I get to work with classroom teachers. I get to work with art, music, dance, and drama teachers, providing professional development. I provide about 6 to 8 professional development workshops in arts integration every year. And I get to mentor and support teachers in the schools, and I get to see children creating art monthly in the schools, which is one of my favorite parts. So we have about 22 arts integration schools that are in the USU region that I get to work with. And my role in this grant is to help develop STEAM or arts integration lessons with the lead art teachers. So I am going to start with defining what arts integration is. So I often do presentations for principals or teachers or my students, and I think it's a great place to start is just the definition of what arts integration is. And this is actually the Kennedy Center definition from the Kennedy Center for the Performing Arts, which is kind of a hub for arts integration research. So what is arts integration? Arts integration is an approach to teaching in which students construct and demonstrate understanding through an art form. Students engage in a creative process which connects an art form and another subject area and meets evolving objectives in both. So I'm going to break that down for you a little bit, because I think when you just hear that or read that, you might still be going, okay, now what is this? So let me break down some of the phrases in this definition. Arts integration is an approach to teaching. Arts integration is larger than an activity. Rather, arts integration is really an approach. It's the arts becomes the vehicle for learning. An approach to teaching refers to how something is taught rather than what is taught. Another phrase I'd like to look at is students construct and demonstrate understanding. Let's break that down. Arts integration provides multiple ways for students to make sense of what they learn. So constructing that understanding and make their learning visible, demonstrate their understanding. So it goes beyond that initial step of helping students learn and recall information to actually challenging students to take the information, take the facts they've learned, and do something with them to build a deeper understanding. So students construct and demonstrate understanding, and then they do it through an art form. So what is an art form? Students can construct and demonstrate their understanding in a lot of ways. Traditionally, students are asked to communicate their understanding through a report or maybe a worksheet, maybe an end of the unit or end of the year test. But when students are involved in arts integration, their learning is evident in the products that they create. So such as a dance or a music soundscape, or maybe a dramatization. And students engage in a creative process. Let's break that down. Arts integration requires that students do more than repeat something, like repeating a song or copying an art project that the teacher creates or follow directions. Students are actually involved in something that's original and of value. And I really emphasize that. And in my class, when I teach pre-service teachers, I give them examples of high quality, authentic arts-based activities that students will create. When students engage in a creative process, they produce original work that communicates their ideas, their insights, their points of view, their feelings. And so students engage in this creative process, which connects an art form and another subject area. So let's break that down. Connections are made between a specific art form, so dance, music, drama, visual art, and a specific curriculum area. So I'm going to give you some examples in a couple minutes, but an example would be a drawing can be connected to the study of the parts of a plant, or dance choreography could be connected to the study of life cycles. So students engage in this creative process, they connect an art form in another subject area, and then it meets evolving objectives in both. What does that mean? Arts integration requires teachers to set those objectives in both the art form and the other subject area. So there's this balance between the objectives. So students are accountable for learning objectives or meeting objectives in both the art form and the other subject. So there you go. There's a little bit of definition or explanation of what arts integration is. So what are the benefits of arts integration? So I've already, I mentioned before when defining arts integration provides multiple ways for students to make sense of what they learn. So again, constructing understanding and making their learning visible, demonstrating understanding. Arts integration also contributes to the development of those 21st century skills like collaboration, communication, critical thinking, and problem solving. Research shows that arts integration, we're gonna go back up, leads to deeper learning, increased student engagement, provides a variety of strategies for assessing content and expressing understanding, engages students in creativity, innovation, and imagination. And the arts motivate students to engage more fully with the subject area, the core content areas. So that science, that math, technology, engineering. But I think one important piece that we often overlook is that arts integration makes learning fun. And a couple other presenters talked about that. Rita and Caitlin mentioned that, going out to the gardens, doing hands-on activities makes learning fun. Not only for the teachers, but the students, but the teachers actually have fun teaching. So when we are designing or developing our arts integration lesson plans relating to the garden-based learning, we will address the national standards, both in the arts and the core content areas, and as well as meet objectives in both the art and content areas of math, science, engineering, and technology. So I'm going to show you a couple examples of elementary arts integration projects that relate to flora, fauna, and life cycles. I think these will help visualize a little bit what arts integration looks like. So my background, I mentioned earlier, is in visual art. So a lot of the examples I've chosen are more visual arts based, but we are going to develop arts integration lessons in all of the art forms. So dance, drama, music, and visual art, and even poetry. So in the first two projects, this one and this one, students are engaging in naturalistic observational drawing. Students draw from live plants, samples either on site at the garden or back in the classroom, and they look very closely at the plants. In fact, I was talking to Lisa Saunderson, who's the Beverly Taylor Sorensen art teacher at Edith Bowen Lab School, which is our lab school here at Utah State University, and they're an arts integration school. She did a very similar project just a few weeks ago where she brought in sunflowers and put them in the classroom in the vases. And she had the students look closely at the plants, study the textures, the way the light affects the color. They looked at scientific illustrations. They did some art history where they studied different artists that utilize plants or flowers in their paintings, such as Vincent van Gogh's sunflower paintings. The students also made observations in their nature journals. So they recorded the changes of the flowers over time. So they kept them in the room and they made observations of how the head started to fall over in the sunflower and curl over and brown and the dropping of the leaves. They also talked about how sunflowers turn towards the direction of the sun. So in summary, in this project, students are looking at scientific illustrations, observing plants, flowers from nature, recording their observation of the parts of the plant, the life cycle of a plant. They're learning math concepts as well, such as radial symmetry and proportion size. They're using a viewfinder to create their composition. So lots going on in this one. In this example, students are learning about the parts of an insect, how insects have developed adaptations to help them survive in different habitats. They're also learning about different pollinators that might visit the garden. In this lesson, they are also learning some math concepts such as scale, proportion, symmetry, and graphing the different types of pollinators that might be visiting the garden, documenting how many pollinators visited, what types of pollinators were there. And the last example I have relates to life cycles. This example relates to the life cycle of an insect or a butterfly. And I was really excited when I heard, I think it was Caitlin talking about, or Rita talking about the bee homes and the possibilities of actually having cocoons to make observational drawings. So in this lesson, students are learning about the life cycle of an insect. So they're constructing that understanding by drawing and painting it, the life cycle of the butterfly, and they're making that learning visible. And those are all of my examples. And now I'd like to open it up for questions.
Hi, Rona. This is Wei Wei. This is a great. I mean, like the art integration, and then the definition was really solid. Yeah, and I think that's a wonderful definitions of, you know, and really tie back to the STEM integrations. And then so I think that's really nice. You know, like components being you know, including in the lesson plan. Yeah, great.
Thank you.
Aurora didn't mention this, but one of her roles is outreach in the state and professional development. So not only is she an arts integration expert, she also is a professional development expert. So she does double function for us on our team. Kathy V made a comment. She wants to come to class with you, Aurora.
I would love it. I'd love to have you in there. I do a lot of hands-on activities. I did want to just add to what Kathy just mentioned. So with my program, with the Arts Our Core program, we plan about 6 to 8 professional development arts integration workshops every year, in addition to a full day arts integration conference here on campus at Utah State University. So yes, professional development, community engagement is a very big part of my position.
Aurora, this is Beth. I just had a quick question for you. I know arts teachers tend to have, you know, kind of depending on their background, a lack of confidence in their artistic ability and the ability to help kids to grow in that skill, like for, you know, especially doing naturalist observations and things like that. What are some of the approaches that you use to help teachers kind of get over that hump and be comfortable supporting that work?
Beth, that's a great question, because I see that a lot with my pre-service teachers, my elementary ed majors. You know, a lot of them, their skill set is at different levels, right? Some of them grew up being a singer or played piano, or some have never drawn. They can only draw, they say they can only draw stick figures. So I think building confidence is a huge part of it, and building in professional development into which is a big part of this this grant, is to help train those teachers how those skills that they would need to teach the students and build their own confidence. And I often tell teachers and my pre-service teachers that you don't have to be this accomplished musician or singer or artist to teach through the arts, right? To teach basic concepts in the arts. You don't even have to have a beautiful voice to have them singing in your classroom, but you do need to understand the fundamentals of those disciplines to be able to teach effectively. And I often talk about that fluff and stuff, like cookie cutter arts. That's not what we're teaching with arts integration. These are not snowmen that all look the same in the halls, right? We're teaching about truly authentic, high quality arts projects and activities. So I think professional development is a really important piece. And I found that even in my class, I've been doing little video tutorials that I will then give them so they can take it with them and like practice it, and or even show it to their students if they would like to do that. So I hope I answered your question. I think it's building their confidence and providing support to them so that they have that skill set that they can bring into the lessons.
Aurora, we have one more question in the chat. It's from Jennifer McAdam. It's how about a dance with a monotony of grasses and a cow that lights up when the legumes and the forbs arrive?
Ooh, I love it. So you're giving me some ideas.
I I don't know if Aurora mentioned this. She strategically selected the 3 teachers. One is in the visual arts, one is in music, and the other one is in movement and dance. So we do have experts in those areas to cover them. So Aurora, do you want to pose your question?
I will.
That'll take us into the discussion.
Yes, so my food for thought, before I ask the question, just to give a little bit of background. So I had mentioned that I do an annual arts integration conference every year, and the last 2 years due to COVID, we had to shift online from a face-to-face to an online format. So that we had to really redesign how to have the conference. So I hired a videographer, a local videographer and teacher. He's a high school teacher in the schools, and he recorded many of the sessions. So they were pre-recorded professional development workshops with teaching artists, teaching about their skills. And in addition, there was some live sessions. So we're hoping to continue to work with him on this project to create these STEAM career documentary videos that Kathy mentioned earlier on, which is a way to highlight and represent scientists, show like a little biography or a little documentary about what scientists do and who they are, like a soil scientist, a plant, a grazing scientist. I wrote climate scientists, again, so students can connect personally to the scientists as a profession. So my question is, what suggestions do you have for the STEAM career videos?
And that will take us over into our discussion section.
And Kathy, I'm just going to mention, if anyone wants to learn more about ArtsCore, the program here at Utah State University, I didn't put my the link, but if you do a search for ArtsCore Utah State University, it'll pop to our website, our Facebook page, and our Instagram. Thank you.
Okay. Thank you, Aurora. Great conversations and questions and information.